Hello, welcome back to Chapter 13, Section 1, where we're talking about right-angle trigonometry. In this example, we're going to be talking about angles of depression and angles of elevation. And I didn't draw this picture, I stole it from the textbook. But it's very good for explaining what an angle of elevation and angle of depression is. Basically, an angle of elevation is when you look up at something. And an angle of depression is where you look down at something. And it allows us to, as I said in the previous video, take indirect measurements if we have a couple of measurements already. The problems will be getting more complicated as we go all the way through Chapter 13, but we're going to start off with a couple of easy ones. Basically, and I'll use this as a picture, as a starting place, if I have my triangle that looks like this, and of course here's u at x, and here's the airplane at y, if this is x and y, looking up at the airplane is an angle of elevation. So this would be the horizontal distance, this would be the vertical distance, also known as the height. So the height of whatever object that you're looking up at. This straight line distance is not going to show up in these problems, but it'll show up later. If I know either the vertical distance or the horizontal distance, and I know this angle of elevation, I can figure out the other one. So if I knew how far it was horizontally from this airplane to the tower, if I knew this distance and I knew that angle of elevation, we could figure out the airplane's altitude. Or, since the airplane probably has an altimeter, if the airplane had knew what its altitude was, and we knew what the angle was, or even from the airplane's point of view, this would be an angle of depression. I'll draw that picture in a second. Then we could figure out the horizontal distance, and we would know how far the airplane needs to go to get to where the tower is, or the airport. For the angle of depression part, the triangle just kind of looks like this. So again, we're looking down, which means I'll write that over here. So this would be elevation. For the angle of depression, we're looking down. That's all that means. But the other stuff stays the same. So if you're at the airplane, and you want to look at where the tower is, I switch the x and y, it doesn't matter. I still have this horizontal distance, and I still have this vertical distance, and of course that would be the height. So again, we're either trying to figure out what the height is, or we're trying to figure out what the horizontal distance is. So here's the example that we're going to do. So a park ranger is at eye level, whose eye level is 5 feet above the ground, so maybe the park ranger is like 5'4" or something, but the eyes aren't at the exact top of the head. Measures the angle of elevation to the top of an eruption of Old Faithful to be 34.6 degrees. So I have an angle of elevation. The park ranger is looking up an angle of elevation of 34.6 degrees. Now, the horizontal distance between the park ranger and the mouth of the geyser is 200 feet. So what we are trying to figure out is what's the height of the eruption. So without all the pictures here, I have a triangle that kind of looks like this, where this is 34.6 degrees. And this horizontal distance is going to be 200 feet. And I want to find out what the height is. Cut X, or I should have said H for X. Sorry, H for height, but I use an X because of the picture. So again, I can use trigonometry. Relative to the angle 34.6 degrees, this side is the opposite side. This side is the adjacent side. So I have tangent of any angle, tangent of theta, is going to be opposite over adjacent So in this situation, I've got tangent. My angle is 34.6 degrees. My opposite side is the side I'm trying to figure out, x, and my adjacent, which is the horizontal side, is going to be 200. So I'm going to multiply both sides by 200, and I get x equals whatever 200 times the tangent of 34.6 degrees is. Grab a calculator. First thing I do is I go to mode to check to make sure that I'm in degree. I left it there from last time. And I do 200 times tangent 34.6, and that's it. So that distance x is 100, and does it say to the nearest foot? Yes, it does. So 137.97 is going to round up to 138. However, what is the height of the eruption? Remember that the park ranger also at eye level is 5 feet. So now we got to add the height of the ranger. So even though that's not x, but the total height of the eruption of Old Faithful is 138 plus 5, which is 143 feet in this problem. 138 plus 5. And again, what we're doing is we're using trigonometry to take measurements that we wouldn't be able to measure directly. The geyser erupts, sprays out steam and water, and then it falls back. So it's an instantaneous thing. You're not going to be able to stand up there with a measuring tape and like pause it and then measure it real quick. So you're going to have to measure it in an indirect way.